Alright, I'm going to go ahead and get started, and like I say, if you do have any questions or any problems hearing me or anything, just throw a question in the question box and I will stop and get right to that. I just assume you do throw the questions in as you get them versus waiting until the end, and that way we won't forget what we were talking about. And today we're going to talk about AC coupled and pre-wired solutions. We'll lightly talk about the three different varieties of battery-based systems just to help differentiate from them, and then I'm going to go right into AC coupled. So there's an off-grid battery-based system, there's a battery-based grid-tie system, and then there's an AC coupled system. And the definition of those, basically, here's a picture of me in my office, so if you do need to get a hold of me, here's my phone number, my extension, my email address. My cell phone is on the website as well. So basically there's three types of systems. You have an off-grid system. Oh, sorry about that. No pictures yet. Let me back up. See if that works. You're able to see it now, I hope. Alright, so I'm going to progress, and basically there's three types of battery-based systems. We have our off-grid systems, which they can be grid interactive, but they can't sell to the grid, so that's kind of a catch that you need to watch out for, especially if you're new to the battery-based systems. Some of the manufacturers, like the one seen there on the website, market their inverter as grid interactive, which basically means it can take the grid in and charge your batteries, but it is not going to sell to the grid. So that particular inverter you see there is not a grid tie inverter. It's what we call an off-grid inverter. So you've got that style of inverter. Then you have a battery-based grid tie inverter, which what it does is it will sell back to the grid. So it does everything the off-grid inverter does, except for it's able to actually drive the meter backwards and sell power to the utility. And then you have what's called an AC coupled system, which is basically, for the purpose of this discussion, we're going to treat AC coupled as a retrofit for an existing grid tie system. And we'll talk a little bit about that. One of the things I want to point out is that AC coupled is usually intended for retrofitting. So if you've got a customer that calls you that has no renewable energy at all right now, and they want to be grid tied but they want battery backup, you really probably want to look at battery-based grid tie. AC coupling is a little clunkier. It doesn't give you all the bells and whistles that a pure grid tie system gives you. So it has some limitations, if you will, and it has some cost. So if you're starting from scratch, typically a battery-based grid tie is going to be the way to go versus trying to AC couple from the beginning. The exception to that rule is SMA equipment. So if you're doing an interesting system where there's a lot of buildings that you're trying to utilize, or whatever the case may be, you can do the SMA systems, and they do a very elegant AC coupling scenario. We'll talk about that a little bit more here in a minute. So quickly, off-grid, like I said, is standalone. It will not sell back to the utility. There's various inverters available for this, for off-grid. Some inverters will actually do both. Some inverters are made to grid tie or off-grid, and some do 120 volts, some do 120 or 240. And we'll point out all the features of each different inverter as we go. Now, grid tie of battery backup looks quite similar. Again, it will sell to the grid. It will run your critical loads during a grid failure, or your whole house if you put in a big enough system. It really depends on the loads, and we'll talk about that a little bit more. And some of the questions you need to know with grid tie of battery backup is, do you need 120 volts or do you need 120 to 40 volts? Yeah, some models support generators, some do not support generators. So that's another question to ask if the customer is doing battery backup grid tie or even AC coupled. Is there an interest in putting a generator into this equation? Because if there is, some inverter manufacturers work better for that than others. So now we're going to jump right into AC coupling. And like I say, basically for the purpose of this exercise, we're going to treat AC coupling as a retrofit for an existing grid tie system. So your customer has buyer's remorse. They've spent a bunch of money on a grid tie solar system. The lights went out and theirs went out too, and now they want to do something about that. So we have several solutions for that. We're going to talk about those. We're going to talk about some of the limitations of each of the different inverter manufacturers as we go through that. And one thing I do want to point out while we got the picture up here, this particular particular system is available as you see it, less the batteries. So it comes with all the cables, the cabinet, and everything. And that's an outdoor rated cabinet. So if you're in an environment where that's inducive and space is an issue, this can actually be put right outside. Batteries can be put in it and can be fit right into the grid tie system and give you AC coupling. Some of the reasons to promote AC coupling and to really learn, and study up on it and market it, it's a growing market segment. With the storms coming through like Sandy did a while back, or any of these natural disasters, or any of the cases that may be happening, a lot of customers are really looking towards AC coupling, because they really want to be able to take advantage of that solar system they spent a bunch of money on that doesn't work when the lights go down. Something else about AC coupling, like I said, it can be confusing. It's not cut and dry like grid tie would be, or battery-based grid tie would be. There's a lot of variables we really have to look at and understand. And it can be complicated, especially if you're buying a box of parts and assembling it yourself. It can really, it can raise a lot of questions, and there's a lot of opportunity to do something not quite right and, melt down a set of batteries or something, or damage an inverter. So there's numerous ways to go, and one of the big things is at midnight with our pre-wired solutions, we've taken a lot of the mystery out of this. So we're going to go through this. We're going to point out the good and the bad of all the different manufacturers and how you can use them for AC coupling. So before we do that, though, I do want to point out, I want to discuss what AC coupling actually is. So AC coupling is a controlled backfeed to a battery-based inverter. So those of you that have messed with a battery-based inverter know that there's a goes in and a goes out. So you got an AC in from the generator or utility, you got an AC out to the loads. And you know that you never want to hook something to the AC out that produces electricity because it'll blow the inverter up. Well, in this case we do, which is a little counterintuitive, but because it's a synchronized backfeed from a grid tie inverter, it will first synchronize to this battery-based inverter, and then it will push back against the inverter's output. The inverter will actually run backwards and charge the batteries. With that in mind, though, because the inverter is running backwards, this is pretty much true for all the inverters except for the SMA, they don't actually have control over what's going on. So it is up to you to limit the size of the grid tie array into the battery-based inverter. And we'll talk about those limits on each particular manufacturer as we progress. The grid tie inverters, some of the battery-based inverters do what we call frequency shift, and that will actually knock the grid tie inverters off. Some of them require relays, and we'll point all that out as we go as well. But again, basically what makes this okay to backfeed this inverter is because we're doing it with a synchronous coupling of that grid tie inverter. So it'll basically match the frequency and then slowly push back against it. And not all battery-based sine wave inverters are capable of backfeeding. Basically your choices in North America right now are the SMA, the Outback series, the Magnum PAE series, and the Snyder XW. The Snyder SW, their new line, it will actually AC couple, but they don't support it. They don't want to support it on that small scale inverter, but it will actually do it as long as you provide a means to disconnect the grid tie on a full battery. So now we'll talk about some of the specifics. So the Magnum and the Outback inverters sense circuits to control charging are on their inputs, not on their outputs. Therefore, they cannot control charging in a reverse state as AC coupled. These inverters will charge wide open and cannot taper off, which means if there's not a provision for disconnecting the grid tie inverter, the batteries will just completely overcharge. So in this case of the Magnum or the Outback, we really need to use a relay to disconnect the grid tie inverter, and basically when the batteries get full, we open the relay, disconnect the grid tie inverter. When the batteries drain down, we close the relay, reconnect the grid tie inverter. It counts as 5 minutes and it starts charging again. The Magnum inverter does frequency dither, but it does it 4 volts above the set point, so it's not a usable feature, because you could spend all day, say 3 volts above the set point, and it's never going to disconnect, and it's just going to sit there and boil your batteries. And speaking of batteries, typically in an AC coupled system, I would really encourage, a sealed battery of some form. Unlike an off-grid system where we typically promote flooded batteries, in an AC coupled scenario, the batteries are going to die of age before they ever die of use. So we really, we want to go with like a maintenance-free battery, for several reasons. But the big reason is that typically the customers that are doing the AC coupling are not the hands-on type of people like an off-grid customer would be. So they're not going to be out there looking at those batteries once a month, checking them, maintaining them, etc. So, you've got a couple solutions. You can set up a service contract with your customer. You can do the maintenance on the batteries, or you can sell them sealed batteries and nobody has to worry about it. And that's another thing I want to point out too on the same front on the batteries is the Magnum, the Outback, and the Snyder do what we call on and off charging. They don't do three-stage charging in AC coupled, whereas the SMA does three-stage charging. But that's, in my opinion, is a non-issue because, again, considering that AC coupling is for emergency power outages, when you're in one of those emergency power outages, you're going to go ahead and abuse the batteries because the batteries, again, are going to die of age before they ever die of use. So those 4 or 5 times you abuse the batteries are not going to affect the life of the battery in any way, shape, or form. So the three-stage charging is not anywhere near as crucial as it would be, say, off-grid. Now, you wouldn't want to do this off-grid because then your batteries would be they wouldn't be getting properly charged on a daily basis. But in an AC coupled scenario, the battery-based inverter is doing 95% of the battery charging, keeping the batteries maintained when the grid is actually present. The other 5% of the time when the grid is not present, then we don't really care if we're doing three-stage charging. SMA and Snyder both use frequency shift or frequency dithering to knock the grid tie inverter offline to stop the charging. Basically what that means is as the battery gets full, the battery-based inverter will change the frequency from 60 hertz, and it will change it off the 60 hertz until the grid tie inverter knocks offline, and then it will drop back to 60 hertz when the batteries drop back down. The Sunny Island can also do three-stage charging, as I spoke of, if the Sunny Boys are in line. So you have to have a Sunny Boy and a Sunny Island. They have to be connected together so that the Sunny Boy knows it's gone off grid when the grid fails. And then the Sunny Island can control the Sunny Boy by frequency dithering and ramp it down in stages rather than doing just on and off. Again, not really that important for AC coupling for a emergency backup system, but if you're doing village power or something like that, you really do want to look at that. Or if the customer has a Sunny Boy in the system already and you can upsell them to a Sunny Island, it will be a nice system, but the Sunny Island, being Cadillac, does cost a little bit more than some of the other options. So if the customer is really looking at price, and it's all about price, it's going to be really hard to beat a Magnum AC coupled system. But if the customer is looking for elegant operation and the Cadillac of the systems, then the Sunny Island is definitely going to be the way to go. The generators in AC coupled, again, like I talked about earlier, if you're doing this and it's in a place where you may get ice storms or hurricanes and the customer's like, look, I also want a generator mixed into this, then the Radian and the Snyder both have 2 AC inputs so that a generator can be added at any time, and provisions need to be made to disconnect the grid tie inverter when the generator is running, but in our pre-wired systems we can make that provision as long as we're aware of that when we wire it. We add a relay to disconnect that grid tie when the generator is running. So if the customer is looking towards a generator as well in their AC coupled system, you probably want to take a hard look at those 2 manufacturers. The Snyder is working really well. They've got some interesting software that really helps, and they're I really prefer that inverter for AC coupling simply because it does frequency dither, and I think that's kind of a nice feature. So now we're going to talk about limits on sizing the off-grid or the battery-based inverter. And I want to stop for a minute and say this up here is really kind of a typo. It should say sizing of the battery-based inverter because it doesn't have to be an off-grid inverter. We'll go back to that XW. Let's say the customer has a little bit of N-phase on the roof and wants to put battery-based in, but he'd also kind of like to put a little bit more PV at the same time. Well, you can throw a charge controller, like a Classic for instance, on the side of the XW. You can feed it to a 3 kW of PV and then AC couple it to the N phase as well, and give them a value added. You know, you can boost their production, and the XW will sell all that to the grid. It will sell the classic production to the grid, as well as passing the end phase through so they can sell to the grid. So you have to really look at the whole situation. So this should say battery-based inverter, not off-grid inverter. So with that in mind, when you're sizing this, the Outback, the Magnum, and the Snyder have a 1-to-1 ratio. And that's not a hard ratio. I want to point out that Magnum runs about 80 to 90%. Snyder and Outback are saying you can run up to 100%. So basically what that means is for every kilowatt of grid tie inverter you have on the roof, you need a kilowatt of battery-based inverter to go with that. So if you had a 10 kilowatt grid tie inverter, you wouldn't want to put in a 4 kilowatt battery-based inverter, because that comes back to the fact that they can't regulate and reverse, and they would just drive themselves right into oblivion on current flow backwards. There's no way to back that down and save themselves. Now SMA is a little different. They have a 2-to-1 ratio, so they have some issues with that ratio though, because they're a 120 volt inverter and they only have a 56 amp relay. So the SMA really can only pass 6 kW through itself. So even though they have a 2-to-1 ratio, you really can't run it there under normal conditions. Now that being said, we do offer a pre-wired single SMA that has a relay board in it to solve that problem, and it will take up to 12 kW of grid tie on top of, you know, the 6 kW SMA. So sizing this stuff can be a little tricky in the beginning. You know, what I'd do is I'd encourage you to give us a call, talk to Kim, talk to myself. We both have a fair amount of experience sizing this stuff for AC coupling. So when you're getting into this, you know, don't be afraid to holler at us for questions. And again, the other thing to keep in mind too is that the customer may not need all of the grid tie solar as part of this AC coupled. So let's say the same customer now has 10 kW of PV, but he's got 2 5 kW inverters, and he doesn't really need a 10 kW battery-based inverter because his biggest loads are only 2 or 3 kW. You could go in and take one of the 5 kW inverters, put it on, say, an XW 6048, leave the other 5 kW inverter connected directly to the grid, and then when the grid fails, he would AC couple with 5 kW, not the whole 10 kW. And that can actually be a nice solution too. So there's several ways to skin that cat. So again, it's not as cut and dry as grid tie. You have to really look at the whole picture. You have to know how big of a battery-based inverter does a customer need to run their critical loads, first of all. And then you need to know how big is the grid tie system and how is it comprised, and do you need all of that grid tie system for the AC coupled? So you really have to kind of draw this all out and come to the conclusion of what you need to make the system work. And we're here to help with that. If you know, especially when you're getting going with this, you know, you can give us a shout and we'll help you get through the mystery of that. So now we'll talk specifically about inverter models and some of the stuff, you know, that sets them apart from the others or causes you grief with them. So the Outback FX series is 120 volts only. It's you can get it in a GVFX, which is grid tied, so it can either be grid tie or off grid, but not both. And they both will AC couple, but the grid tie models do not play well with generators. So going back to what I was talking about, if you wanted to add a charge controller on here and put a kW of PV into it through the charge controller and another 2 kW through the grid tie inverter, you wouldn't be able to really bring a generator into this as well. So that's something to keep in mind. They're smaller scale, so they're more affordable on a smaller byte, and they are expandable. They're available in 12, 24, or 48 volt models, but they are 120 volts only. And something to keep in mind when you're AC coupling is you need to match the voltage of the grid tie inverter, and just about every grid tie inverter out there right now is 240 volts. So that would mean you need a pair of these or an auto transformer. Just a quick picture showing some of the things we can do. This was a quad stack that we built. This was an actual off-grid system. And then the Radian. We'll talk a little bit about the Radian. Basically, it can grid tie or be off-grid. It does both. It's 120, 240 in a single unit. It has 2 AC inputs, second one for a generator. It is 8,000 watts per unit and stackable and 48 volts only. It does require a relay for AC coupling, so it does not frequency tether. Something else to keep in mind if the Radian, I'm not positive on the Radian, but I can tell you on the VFX, GVFX, they will not run at nameplate all day. They will get hot and they will back themselves down. So if you're trying to design a battery-based grid tie system and the customer says, I want to put up 3,600 watts of PV, you wouldn't want to put a 3,600 watt GVFX because it would start to derate as the day went on and would sell less and less to the grid as it got hot. So that's just something to keep in mind. Here's a picture of a Radian with a couple of classics on it, pre-wired inside. And there's a picture of the whole system with the battery combiner, 1,000 amp battery combiner on a back plate. So now we'll talk about Magnum, probably the most common AC coupled system that we make. I would say we probably sell 5 to 1 of these. The Magnum comes in 120 volts or 120/240. The PAE model is the model that Magnum recommends for AC coupling because it does have frequency dither, but it is 4 volts above the set point, which makes it pretty much useless. They do come in various wattages, so you can size it more accordingly if you've got a small system. Just need something small scale. They are stackable, and they are vented only. So I should point that out, that the FX series from Outback is a sealed, semi-sealed inverter, so it's pretty impervious to moisture and stuff. It's not meant for outdoor use, but it is fairly sealed. And the Magnum series is off-grid only, so this is great for AC coupling, but you would not be able to put a charge controller on it and sell a little bit extra back to the grid. It does come in 12, 24, or 48 volt models as well. And there's another picture of the outdoor cabinet. This is a Magnum in an outdoor cabinet with 4 batteries wired up for 24 volts, all set to go for AC coupling. Bring your grid tie in, bring the utility in, bring the critical loads panel in, and you're ready to go. That's a picture of one installed outside a residence. And this picture here, what I'm trying to point out is this was a creative installer who had too much PV for the Magnum. And he took a solid-state relay in his combiner box, ran 1 string of PV through the solid-state relay, wired that solid-state relay down to this wall wart plug-in transformer, which is plugged into a utility outlet. So when the utility fails, the outlet turns off, the relay opens and drops a string. A little bit of work, but like I say, being an enterprising installer, he found a way around the problem without putting in 2 Magnums for his customer. So we'll talk a little bit about the XW. It, as well as the Radian, is grid tie or off-grid. It supports both. It's 120/240 in a single unit. It has 2 AC inputs, second one for a generator. It's available in a 4 kilowatt, a 4.5 kilowatt, or a 6 kilowatt unit. It is stackable, and it comes in 24 or 48 volt models. So this is a nice solution because it does do frequency dither. It does have both inputs for the generator. It will allow you to add a little extra PV to it and sell that back to the grid in conjunction with the AC coupled if you want. So this just kind of makes a really nice all-around inverter. And then we get into the SMA, the Sunny Island stuff. And here's where it does get a little interesting. The system as you see it here is an inverter, an auto transformer, and an E-panel. The Sunny Island is 120 volts only. And something else about the Sunny Island a lot of people didn't realize, it is a grid tie inverter. SMA doesn't really market it that way. I guess they just assume that you're going to always do a Sunny Boy. But a Sunny Island will actually sell to the grid with charge controllers as DC coupled. So you can use this as a grid tie inverter or an AC coupled or an off-grid inverter. It is a single input, but you can add a transfer switch to that if you need a generator. You do have to supply the Sunny Island of a digital input to let it know that it's off-grid. that it's on generator, so it will not sell back to the generator. So it's a little more difficult to add a generator to it than it would be, say, like the XW. It does come in a 4.5 kilowatt and a 6 kilowatt unit. It is stackable up to 4 units, and it is 48 volt DC. Now, I should also back up and talk a little bit about 3-phase. I don't know how many of you work in 3-phase or deal with AC coupled in 3-phase, but the the Radian will not do 3-phase. The FX series will do three-phase, the XW will do three-phase, and the SMA will do three-phase. The Magnum, I do not believe, will do three-phase either. So if you're into three-phase, you're really into the SMA or the XW, if you will. And here's just a quick picture of a quad stack of SMAs with the battery combiner all wired up. You can do multi-clusters of Sunny Islands if you're doing three-phase. Again, that gets a little more complicated. You need their multi-cluster box, but you can do up to 4 stacks or 4 clusters of Sunny Islands and up to 3 in a cluster. So you can do 12 Sunny Islands in what they call a multi-cluster. And feel free to give us a call with any SMA questions. We can help with designing a system for that. So that brings me to the end of the slideshow. I don't know if I've got any questions. If I don't, I was going to run through the website real quick and show you the current offerings for pre-wireds. So far it's been pretty quiet on questions. All right, so on our website, if we start right out at the home, midnightsolar.com, you'll notice we go to products, and then we go to inverter systems, pre-wired, AC coupled. And this is where you'll find all the current offerings for AC coupled, and we try to keep everything up to date as the manufacturers change their specs on what you can and can't do as far as how many watts you can put on it and everything. I've got a question here that asks if the Radian is off-grid. The Radian can be used off-grid, but it is also a grid tie inverter, so it can do both. So you could use it in a battery-based grid tie system, you could use it purely off-grid, or you could use it in an AC coupled system. So onto our website, what I wanted to show you here was just the products that we offer. So we have, again, the one in the outdoor box, the Magnum, good for about 3,800 watts of grid tie inverter. We have the same thing but in a wall mount package if it was going inside. Again, same good for about 3,800 watts of grid tie inverter. And we have the dual Magnum. So we can do up to 4 Magnums in an AC coupled situation if needed. And over here you can see the relay for disconnecting the grid tie inverter. So there's literally a set of bus bars right here that say grid tie inverter input, goes through the relay, through an overcurrent protection, and then over the output of the Magnums, so it's all isolated. And then we get into the Snyder equipment. We only have the 6,000 watt inverters listed here, but we can do the different ones. If you look down bottom, we can add an automatic generator start. We can do the 4,500 watt. We can do the 4,000 watt, or we can even pre-wire it with a classic if you want to add a classic to it to do, to do a grid tied with DC coupled and AC coupled, what I would call a hybrid system. Going to stop for a minute. That's news to me. Is it just the new Radian? No, the Radian inverter has always been a grid tie inverter. It's always been grid tie or off grid. It'll do either. It's got 2 inputs, and it will, it will work just fine. And the next question is, I thought that more than 4 Sunny Islands require a multi-cluster. That is correct. 4 Sunny Islands can work together. If you need to do a bigger system than that, it will be 3-phase. The multi-cluster is 3-phase only, and you can do up to 4 clusters in a multi-cluster system. So you have to do them in groups of 3, and you can do up to 12 inverters, but it is what's called a multi-cluster system. Requires SMA's multi-cluster box. Okay, I'm being told that Outback is saying that they recommend you only run about 75% on the grid tie side of things. So if you've got a 8 kW Radian, you really only want to run 75% of that for grid tie inverter. And that's, to answer the question, it's kind of a loaded topic, if you will. And I know like Magnum has changed their mind on that number 3 or 4 times. And what it really boils down to is, again, that Magnum inverter or that Outback inverter, it's an 8 kilowatt inverter, and you start pushing it, and say you have an edge of cloud event or the grid tie inverter overshoots for a minute, that inverter has no way of protecting itself, and it can't it can't back the current down and save itself from blowing up. So that's why the manufacturers like a little bit of headroom. So probably good system design all around would be to say on the Magnum, the Outback, to allow yourself about 25% of headroom. So oversize the battery-based inverter a little bit. And on the Snyder system, we can do a dual AC coupled. The limitation on the Snyder is a single relay. So these guys will allow you to stack multiple inverters, but you can only AC couple up to 60 amps at 240 volts, no matter how many Snyders you have. And that's because they don't want to take the chance of the out-of-sequence relays, even by a millisecond, and have all the load through a single relay and have relay failure. So they're actually being proactive and looking at it from that respect. Magnum is saying, no, you can stack up to 4, and they're not worried about the relays. So those are just, a couple nuances there. Again, like I was saying earlier, about each one having its own little set of hurdles or challenges for you as you design around them. And then we get into the SMA stuff, and really, like I say, in the SMA stuff, we offer a single all the way up to a quad stack, and we can help you work with a multi-cluster system if you need to. We have battery combiner boxes that work excellent in multi-cluster systems, because in a multi-cluster system, the E-panel is not necessarily required, because you don't need the AC breaker systems, because that's all in the multi-cluster box. So you can put a battery combiner box under 3 Sunny Islands. You can put the battery breakers in the battery combiner box, and then you wire that up to the multi-cluster box, and it makes a real elegant looking install, and it's real easy to work with in that scenario. So that brings me really to the bottom of it. I was expecting a ton of questions, so if anybody's got any, feel free to shout them out now. How about you, Kim? You got anything? If you want me to unmute you for a few minutes, raise your hand if you do. All right, well, it seems like we don't really have any questions. You all know how to get a hold of me. You can call the main number. I can pull up the website and show you the main number. And feel free to give Kim or I a call, and we can talk about AC coupling. Right down at the bottom of our homepage, right down here, is contact info for all of us. And my cell phone and everything's on there. Kim's extension's on there. So don't be afraid to holler at us anytime needed. And I guess if there are no questions, we'll go ahead and wrap this up. This is recorded, so I will get it up on our YouTube channel as soon as possible. And any questions, feel free to give me a shout. And thank you, everybody, for taking time out of the day to come listen to me. And feel free to holler. Talk to you later.